thank you guys for coming. By the way, these are the new and improved code quality talks. We have Dave Astle has been doing a great job revamping them, and so these are the new and improved ones. So if you've seen it before, come again, and we'll do it again. Is it not? Oh, I have to talk over here, huh? I'm so used to the clip-on microphone that thanks for reminding me. Okay. So today we're going to talk about basically conditionals and polymorphism and how that affects testability. So here's the premise, and this is a bit of a crazy premise, and that is back in the day when we went from the basic world is not even procedural languages. What are they called? Well, the basics of the world into procedural world, we were able to get rid of go-tos. And I don't think anybody has really missed them. So here's a crazy thought, and that is if you go from procedural languages to object-oriented languages, you can get rid of quite a few if statements. I'm not going to go as far as say all of them, but for the most part, you can get rid of most of them. It's actually kind of fun to see if you can try writing code without an if. It's a very unique way of writing code. As a matter of fact, there's even certain languages out there, like Smalltalk, where the concept of if doesn't even exist. It's not part of the syntax of the language. So why would you want to get rid of an if statement? Here, well, the thing is that code without ifs are easier to read. And I don't think anybody can really argue with that, right? If you can just read code straight, do A, do B, do C, do D, well, it's pretty clear what's happening. Whereas if somebody says, well, do A, but then sometimes do B, and some other times do C, and then maybe you do D, well, it's kind of confusing as to under what condition, what's happening, and what's the output. And so because it's easier to read, it also turns out that functions without if statements are easier to test. As a matter of fact, you only really need probably one test, maybe a couple of tests for exceptions, but for the most part, one test will do because there really is only one execution through your code for this particular function. And as a result of all this, polymorphic systems or systems that do not use if statements tend to be easier to maintain, easier to understand, easier to extend, and therefore those are all properties of things that we really like and we look for. So how do you get rid of if? I guess a better question is, you get rid of if by using polymorphism in its place, whereas you dispatch into a method whose binding is not known at compile time. Right? This is good old polymorphism where you have a class and a subclass and you have two different instances, and when you say print, it's not clear whether you are printing to the printer or printing to the screen because it's a PDF. So you want to use a polymorphism if the objects should behave differently based on its state. And we're going to talk about an example of what that means. And you should also use polymorphism if you have to check the same condition in multiple places. This usually happens with flags, where you want to enable debugging or disable, and then your code is sprinkled with a bunch of if statements saying, if this flag is enabled, then do this extra stuff over here. So let's have a look. But before we go there, I want to point out that there are certain places where you cannot get rid of an if. If you're comparing if 3 is greater than 7, there's no other way of doing it other than an if statement. So for comparison of primitive types with a lowercase int as opposed to the uppercase integer, you really have no choice but to use an if statement. But we're not going to focus on that. We're going to focus on where the business logic should behave differently. That's the interesting part. Also, I want to point out that if you really want to be if-free in your application, the thing you have to do is you got to make sure you don't return nulls. And we kind of talked about that earlier in earlier talks, how nulls are your friends inside of your tests, but really your enemy inside of production code. You really don't want to get in the situation when you return null, because when you return a null from a method, you can't dispatch off on null. You'll get a null pointer exception. And so what you need is you need to put an if statement over there to make sure you don't dispatch on null, and that clutters your code. And so we want to get away from that. So you simply want to always be in a situation where if you have a method, the method needs to return some kind of an object that probably doesn't do anything. Typical example of this would be like the null logger. If I need to log, I'm always logging, except sometimes I get a relogger that logs to the file system, and sometimes I get a logger that just eats all my messages and doesn't do anything. But not all is good and great. You got to be careful not to go on crazy with subclassing. When you have deep inheritance hierarchies, that creates problems from not just testability, also from understandability, and a couple of other abilities probably as well. So it's a very fine line between getting rid of your ifs and at the same time not turning your application to one ridiculous inheritance hierarchy. So let's look at the first case of where you can get rid of an if, and that is getting rid of in case of where you have state-based behavior. This is quite common if you, for example, have a conditional that chooses different behavior based on its type. Typically, the way this thing happens is you have some kind of field inside of your object, and then based on whether this field is set or a flag, you behave differently. And really what we want to do is we want to say, okay, when this flag is on, all of this stuff that happens differently should really go into a subclass. And when the flag is off, all the stuff that happens when the flag is off should go into this other subclass. And then the common logic stays in the superclass. And that way, we can separate the ifs from the non-ifs, or from the flag turned on from the non-turned on. Simple stuff. This is described in the refactoring book. So by all means, if you have one of those, we do suggest you read it and you use it as a reference. But let's go look at an example of what this thing would look like. So suppose you have a method such as get speed, and it does a switch operation, and on a switch operation we return different things. This is typical things that people do inside of their code. Any suggestions on how to improve this? Subclasses, exactly. And don't we already have a type system? Like if you're switching on a type or the type of bird you are or anything like that, and based on that you're doing different operations, we already have a subclass system, and so we should take advantage of this thing. And so, solution for this is quite obvious, right? You have your base class bird, and you have your European, Norwegian, and African swallow, and then you can subclass it out and have different behaviors in different locations. So this is my favorite questions I love to give on interviews. I don't know if I don't think I've interviewed any of you guys in the audience, but the premise is very simple. You have a mathematical operation such as 1 + 2 × 3. And you want to represent this as a tree. So as a tree, it will look like this. And I'm sure you guys are all familiar with this. And so I would like to have a way of storing this in memory. So I need to have some kind of a class, let's call it a node, which stores this tree. And then I want to perform operations on this. And for the purpose of the example, let's say we want to perform evaluate method on it, which computes the result. In this case, 2 × 3 is 6, + 1 is 7, right? But while I'm going through the examples, I want you to also think about the typical class such as node would do other things, such as toString operation, let's say. And a toString operation should print the tree, placing the parentheses only when necessary. But a real class could have lots and lots of other methods that can do lots of other things. So once you get into a real class situation, the issues you're going to see in the next couple of slides are going to be even so much more important. So just keep an eye on them, and just keep thinking as how this would affect your toString method as I go through the evaluate method. So we want to have an evaluate method that computes the result of an expression, pretty straightforward stuff. And what we want to do, when you give this problem to most people, this is what the solution they come up with is. They say, I have a class node, and I'm going to have an operator on it, which basically says whether I'm a plus, multiplication, division, and so on. And then I'm going to have a value, which is the number that I represent. And I'm going to have the left child and the right child. And my evaluate method would then have a switch statement that switches on the operation I am, and then perform the operation you want. Now, keep in mind how the toString method would mimic this, right? Your toString method, in order to get the infix notation printed, would essentially mimic your switch statements here. But there's actually a bigger problem with this. Before we go there, let's kind of do a graphical representation of this, right? So you have your node, as we pointed out, you have your 4 fields and 1 evaluate method. And this would represent into a structure such as this. Notice a couple of weird things in there. Our leaf nodes still have the left and right child, and they're pointing to nulls. And we already said that nulls are not a good idea in production code, right? And so we're going to trip up over our null values by having the possibility of having an NPE. So you want to kind of get rid of that. Also notice on something else, which is the plus and the multiplication node has to keep around 0, even though it's a completely meaningless concept for a plus or multiplication to have 0 associated. We have some number, we have to give it something over there, right? In our case, we chose 0. So it has information that it doesn't need, right? So there's two different behaviors that are kind of fighting in here. And so the different behaviors are basically if you're an operation node, then you need your left and right child. Whereas if you're a value node, you just need the value. And you can see that in the presentation, how I either need the value or I need the left and right, but I never need both. And that usually is a perfect example that you have a class that has multiple responsibilities all entangled inside of it, and then there's some kind of a polymorphic behavior going on, but the polymorphic behavior is going on through fields and if statements, not through polymorphism. So let's break this up. Let's take our node, and we say we're going to have a value node and operation node. And by breaking this up into value and operation node, what we can do is we can take the value and shove it into the value node, which is the leaf node. And we can also get rid of the left and right child for the leaf node because it has no meaning over there. And so this is a good way of separating it out and then simplifying this thing. So we would have our standard issue node with the evaluate operation, and then we have the value node, which extends the node and defines the evaluate method to simply return your value. Notice how simple the value node is, right? There's no if statements in there. There's no possibility for null or NPE or anything like that. But we're still left with this op node, which has this nasty switch statement inside of it. Now I want to point out at this point that think about how you would extend this. Not only do you have to worry about having your toString method and your evaluate method mimic each other, but every time somebody wants to add a new operation, they have to recompile the code. Not only do they have to recompile the code, they have to get a hold of their source code first. So if this is meant to be as a library that a third party is using, they might not have the access to the source code, or maybe they don't want to recompile the library, right? And so let's see if we can do something better. So with this change, this is how the tree looks like, right? We got rid of our nulls for our leaves. So we're making good progress. And now when you have operation node, it no longer has the 0 that was stuck over there before. And so this is definitely a progress in the right direction. But we still have the same problem as we had with the swallows in the previous example. And that is that the behavior of the node changes based on a type. Or in this case, it's the operator field, right? So depending on what the operator field is, our class behaves differently. And that's something we want to avoid. Rather, we want to take advantage of the construct of a language, which is the polymorphism, to take advantage of this thing, rather than encoding it using if statements. So again, let's focus on the addition and multiplication, and let's further subdivide this into a operation node where we keep our left and the right, because all operation nodes have left and right children. And we now just have evaluate, which continues being abstract, and it becomes concrete in the addition node and multiplication node. That's where we have the actual implementation. So from a coding point of view, right, we still have our value node. Now we have our abstract op node. We keep our left and right at this level. And now we have the addition node and multiplication node, which does the actual operation. Notice what happens in here. First of all, the possibility of an NPE has disappeared. Because operation nodes needs a left and a right child, and therefore it will never throw an NPE. Whereas the leaf node doesn't have left and right child, and again it will never throw an NPE. So we can really clean up the code simply by breaking it away into smaller subclasses that do individual pieces of work. Again, keep in mind that in addition node you would also have to implement a toString method that would know how to print the the plus operator. And in the multiplication node, you would have to write a two-string method that knows how to print the multiplication operator, and so on and so forth, right? So it no longer is a bunch of switch statements in different methods that have to all mimic each other. They're now separate subclasses. And if you wanted to add a new operation, it's very clear as to which methods you have to override and what you have to implement over there, right? I know I have to implement the evaluate method because it's abstract, and I know I have to implement the two-string method. And therefore, I can easily, any new person who comes to the project doesn't have to be explained or doesn't have to go through the code in great depth. It's very obvious as to what needs to be done because it's simply the code doesn't compile any other way. So after all this, we basically end up with addition node and multiplication node. And again, notice how the addition node and multiplication node now don't have the operator field. Not only do they have no operator field, they also have no value field, which we originally had at the beginning. So they went kind of on a diet. They became just the meat of what needs to be done. So we kind of talked about the two-string method all throughout the presentation. But this is a good point to kind of reflect on how, in real-world projects where you have multiple, you might have evaluate method, you might want to have a print method and a couple of other things, how it really helps the situation because you have one structure that you deal with, and you don't have to go through multiple places and remember where everything has to change. So I'm going to argue that a polymorphic solution is oftentimes better, specifically because the new behavior goes into a separate subclass, right? All of the behavior specific to addition goes into one subclass. All of the behavior specific to printing leaf nodes goes into another subclass, and so on and so forth. And that actually makes it easier to test. That makes it easier to understand. That makes it easier for people to extend and maintain. All of those are good qualities that we're looking for. So that's one way you can get rid of an if statement. Right, before we get there, so switch statement, whenever you see switch statement in your code base, that's usually a clear sign that polymorphism is begging to be there. It's almost a rule, I would go as far as saying. If statements are more subtle, and most of the times we want to get rid of ifs and add polymorphism, but there are certain cases where you want to be pragmatic about it. But let's talk about the other situation of where you want to get rid of if statements, and that is when you have the same condition all over the code base. Let me give you an example. Suppose you have a method class called update, and there is a method called execute, and based on some flag, you have to do either A portion or the B portion. You might think, yeah, it's not so bad. I just have a flag, and I do different behavior depending on whether the flag is set or not. Well, I would already argue you probably want to have a polymorphism at this point, but it's still just a single if statement. But at some point, you have a rendering method. And now the same if statement appears again. And when you start repeating the if statements over and over and over again, that's a clear sign that what you want there is polymorphism. The reason for this is because if you look at the do A part and the render A part, they both get executed together. Similarly with do B part and render B part, right? Those pieces get executed together, and the rendering pieces the A parts get executed together, and the B parts get executed together. And it's not like you can execute A and B. Actually, that would be a bug, right, if you could execute A and B. And so you really want to make sure that the conditions are same. Preferably, you want to get rid of the conditions. Now, from a testing point of view, this becomes a problem because not only do we have a global variable, which is the flag, which is usually how command line flags get dealt with, but it's always, you're not really sure, like, did I really cover all the if statements? Because are these if statements really combinatorial? Like, is it possible to execute A, do A, and render B, or is it not? It might be easy to see in a simple class like this, but if you have a very complicated class with lots of code base, it's not clear which conditions go together with what. And so you might end up trying to test things that can't actually happen in production. And so what we want to do is we want to really separate it out. Same story as before, and that is we want to use polymorphism to our advantage. We want to take the A parts and put them in one class and take the B parts and put them to the other class, right? And the work over here is pretty straightforward. you create an abstract superclass, which is the update, and now you take the A parts, whether it's a do A or render A, and pull it out in a separate method called render and execute. And you do the same exact thing for the non-international class, right? So now you have two subclasses representing what you wanted to do. Now, from a testing point of view, this is great, because when I instantiate an internationalized subclass, I know exactly what I'm talking about. It's not some flag that got set somewhere else. It's a concrete class that I can associate with. It significantly lowers my cognitive load when I think about the test. I don't have to think as hard when I deal with this thing. And I have a separate test for the other subclass, right? And again, I don't have to think about all the nuances. Not only are the tests separate, chances are that being international and being non-international requires you probably to have a different setup method, will probably require different fixtures and different ways of testing it. So that further helps by separating the different kinds of tests out. But the if statement really didn't disappear. The if statement is still there. Rather, there's two different kinds of if statements. There's if statements that is in the location where the original if statement used to be, which is the polymorphic behavior of your code base. But there's also the original if statement just got moved somewhere else. And that is, if you are a consumer of the update and you say, I need to get a hold of the update, what you're really saying is I need either the international or non-international one. But you don't know which one it is, and it's really not your business to care about which one you get. So somebody else is responsible for instantiating the correct subclass of what you want, which gets us back to the good old dependency injection, which is that you have two piles of objects. You have the piles of objects, which does the business logic. This is where the stuff actually gets done. And then you have piles of objects that are responsible for the object graph construction. Again, for those of you guys who have been here before on these talks, you know, we cover this many times over because it's really, really important. By separating the objects out into the objects that do business logic and the objects that do construction, you can basically move your if statement from being inlined inside of your code, which was inside of the update. It used to be just if international do something or something else. You move that if statement into the factory. So now the factory says, maybe I have to instantiate an international version of the update because the consumer is asking for it, as opposed to making the decision inline in your code. Now that actually can have great benefits in terms of performance. Because you don't have to make the decision over and over and over again as the code runs in some kind of a tight loop. You make the decision once, you instantiate the correct subclass, and it gets inlined. It turns out many modern JVMs can actually inline that for you. So a modern JVM will, for example, notice that nobody has ever instantiated the non-international version, which is probably true because you're only running your application in either one mode or the other mode. And when the JVM notices there's no other subclasses of this thing, it will go and inline these operations, which is great speed performance improvement. Now, if you're using something like Juice, you know, you can take advantage of providers.
Can you see what was the fun stuff?
The fun stuff is your business logic.
Oh.
This is why we are the software developers, right? I live and breathe to make code, and my code is mostly the fun stuff, you know, the logic, the stuff that makes the cool applications, right? The factories are the boring stuff of like, I gotta wire it together so that it runs, right? It's no good to have a cool algorithm that can sort your data. You need to have some kind of wiring that says, okay, instantiate the sorter, instantiate the reader, instantiate the file system, and then hook it all together, and then kind of orchestrate the whole thing. Those are the differences between the business logic and your new operators, yeah? Or your factories are your new operators. And we kind of mentioned that how important it is to separate your new operators from your business logic, because you want to be able to inside of the test, you want to be able to instantiate a small subportion of your application. And by mixing the new operator together with your application logic, you don't have the control in your test of instantiating things in isolation. And that kind of prevents you from being able to test things. So we kind of cover this, right? But the business logic is responsible for doing work, right? And the constructors or the factories are responsible for wiring the objects together, building you the object graph, right? The reader talks to the filter, talks to the writer, which talks to the database, right? The wiring magic happens inside of factories. That's where your new operators end up. It is also where some of the if statements end up, because you want to get into a situation where your application behaves differently, not because you have if statements and flags sprinkled all over your code, but it behaves differently because you wired it together differently. And that's a big aha moment, right? Because when you can change the behavior of applications simply by the way you wire it together differently, you have a lot of possibilities of what you can do at runtime in terms of compile time, in understanding, in maintaining it, and in extending it. So if you're using Juice, for example, the constructors could be your dependency injection, right? This is what creates the providers, which hooks things together, where the actual original check into the flag is made to see if we are international or we're not international, and then we can subclass we can instantiate the correct version of it. Now, going back to the international example, it turns out that when you subclass things into international and non-international, chances are that the two subclasses will actually have different set of arguments in their constructors. And that's actually important, because if you're an international, chances are you're going to need certain classes that you don't need when you are non-international. And if you have a single class where everything is done, then you're forced to create all the objects and pass them into the constructor, even if they're not needed. So let's have a look at this. So you have a consumer and it wants the update. So what you need to do is to create some kind of a factory, right? This is where the new operator is for the update. And this is where the if statement happens. We are either instantiating the international version or the non-international version. So the if statement has moved from being inlined in your application to being inside of your factory. And that's a great advantage. That's what we're looking for. If you're using Juice, this gets even better, because then you can simply create a provider, and you can create provider of international, which is automatically done for you. You can ask for the provider of international version. You can also ask for the provider of non-international version. And then you can simply ask for the flag. So you can go a step further, and you can get rid of the dependency on the global variable. And now you can simply test. You can simply say, OK, get me the correct provider location. So now you actually make the provider testable, because all the pieces are fully injectable. So the benefits of this is the conditionals, as we pointed out, of the decision of are we international or not, has gone into a single location. So we took a whole bunch of independent ifs, and we collapsed them into one if, and we moved that if from being inline in your application to being inside of your factories. We got rid of a lot of duplication in the process, and duplication can cause errors, right? If you discover that your if statement has an error, now you have to go change all the if statements that are spread all over the code. Now we have only a single if statement, so if there's an error in the if statement, we can easily fix that. And it also allows you to separate yourself from global state. Like originally, we were doing an if statement on a global variable inline. Now that nasty global variable ended up in some factory. So from a testing point of view, yeah, I might still have a hard time testing the factory, but I have easy time testing my logic. So we have taken something that we consider bad, and we have moved it to some other place where it's still bad, but because of where it is, it doesn't cause as much problems for us. So the benefit of using polymorphism instead of if statements is that you simply have a single locations where all of your related items are together. The multiplication example, we had the multiplication logic, we had the two-string logic. It's one location. In the rendering example, we had a single location where we could put the rendering and the operations for the update in single place. And that greatly aids in the cognitive load when I think about this thing. Not only does it help with cognitive load, it also helps with testability, understanding, and makes it easier when you look at the subclasses to figure out what the differences are. right? If I look at international, non-international version, I can easily see what the difference between the two of them are, because the common stuff is in the superclass. I don't have to worry about that. I simply have to worry about what is different between international and non-international version, or what is different between multiplication and addition. I don't have to worry about the common stuff because that's somewhere else. Anyways, behavior. So you want to use polymorphism. We covered two different things, and that is you want to use polymorphism when the behavior changes based on state, right? Which was the example of the multiplication, where we had a flag, and based on that flag, which was whether it was addition or subtraction, we did different stuff. Or you want to use polymorphism when you have the same if statement over and over and over again. This typically is done with flags. But at the end of the day, right, you got to be pragmatic, so don't go crazy. I recommend that you try writing a small project without any sort of ifs. Just say, I'm going to try it without ifs. And you're going to learn a tremendous amount about how you can take advantage of polymorphism in a lot of different ways. It's worth the experience. But at the end of the day, you be pragmatic. If there's a simple if statement that I can throw somewhere, that's fine. But when it becomes too many if statements, polymorphism really is the way to go. The thing is, if statements creep up on us. You throw in one and you're saying, I'm being pragmatic. Comes along somebody else and he's extending the code, and now he says, well, I'm just doing what the other person is doing. And now you're no longer being pragmatic. You are now duplicating code, but you're not realizing it because you didn't write the original if statement. And so Bart says that you promise not to abuse conditionals in polymorphic languages and instead use polymorphism for it. Anyways, I'm going to open it up for questions. By the way, I want to point out that this might sound like an obvious stuff, especially with the example of multiplication. But my empirical evidence of looking at other people's code tells me otherwise. It's one of those things that when you see it, people say, yeah, clearly it's obvious. Yes, that's how it should be done. But then when you go inside a code base, all you see is if statements everywhere and very rare use of proper polymorphism. Do we have a microphone? I guess we don't. Yes, I'll repeat your question.
So I was just noticing that the first example that you gave, expressions, it was a lot more concise. So I wonder if there's another way to kind of get something that's really concise, but at the same time has them. It's just a trade-off.
So you're saying that just to repeat the question, you're saying that the example of additional, the math example was too concise, and
It was nicely concise.
it was nicely concise, okay? And so you're wondering if a different example would be uglier? Is that what I'm hearing?
I think that just an objection is raised about this non-if or polymorphic approach. Well, the original way of writing it was just one file. It was pretty short.
Yes.
You could see whatever. You could look at one file and see what else is going on instead of having to jump around all these different files.
Right. So your objection is, or the question you have is that many people could argue that a single file with the node where you had a switch statement is clearly easier to understand than a whole bunch of smaller files. I have an issue with the word clearly over there. To me, it's not that obvious. And again, it goes back to, you write a simple node class that today is just doing node operations and additions and subtractions, and tomorrow somebody adds something to it and they have to duplicate the switch, and so on and so forth. To me, this is not even a question of pragmatic. There is a concept of an addition, and the concept of an addition has behavior, adding to numbers. And in the OO world, behavior deserves to have its own either a method or a class where it lives, right? Now, in order to dispatch to the behavior, you would have to go through an if statement, which is what we kind of don't want to go, because we know it's a slippery slope where we say, yeah, one if statement is okay, we're being pragmatic, but soon enough, we have a file that's 5,000 lines long, and there is if statements everywhere, and nobody can quite figure out what's going on. Especially with today's day with modern IDEs, the cost of creating a new class is essentially zero. So, or traversing it, or finding who the callers are, etc. So there's no real problem there. Where people actually do get into problems, which I see often, is they don't separate responsibilities of objects. So a single object has too many responsibilities. Now, keep in mind that your object can only have one inheritance hierarchy, which suggests that you really should only have one responsibility, because that's you can only take advantage of single polymorphic behavior through a single inheritance. And the way around that is, or rather not the way around it, it's not a workaround, it's a good idea, is you should break it up into lots of small objects that collaborate with each other.
We should put that, because you can actually be polymorphic, not only on who you inherit from, but also any interfaces that you use.
Yes, but you remember what we did, sorry, to repeat the question for the audience, you were saying that you could be polymorphic on multiple methods. That is true, but the polymorphism is decided on at the point where the new operator is instantiated, right? And at that point, you cannot say that these two methods will be polymorphic onto this behavior, but these two other methods will be on this other behavior, right? It's all or nothing proposition. So all methods have to end up in the same subclass. And for that reason, you have to clearly separate responsibilities of objects. Otherwise, you have two responsibilities, and those two responsibilities will want to have two different kinds of inheritance, and they will be fighting. Or put it differently, when I am in a team and I see nasty use of a switch and I say you should do polymorphism, the most common suggestion is, but I can't, I already have a specific kind of inheritance, right? And the answer to that is, well, that means you're mixing responsibilities inside of that object. Really, there is a whole bunch of related objects living inside of this one object, and their behavior is controlled by a whole bunch of flags as opposed to collaboration. All right, guys, thanks for coming. We have these talks every week. We always have a different topic. These are new and improved talks. So we appreciate feedback. Also, as I always point out, I do have a whole bunch of the Java reviewers guides. So if some of you guys want one of those, I'll be happy to give them out. Thanks for coming, and we'll see you guys next week.